All right, here is part 3 of section 4 for this redesigned SAT practice test number 1. So this is the calculator section, and in this video I'm going to talk about questions 21 through 30. So in prior videos I did 1 through 10 here, and then 11 through 20. And so I'll pick it up on with this one on number 21 here. So this is some study about dreams recall. The data in the table above was produced by a sleep researcher studying the number of dreams people recall, blah, blah, blah. Group X consisted of 100 people who observed early bedtime, so these people went to bed early. Group Y consisted of 100 people who observed later bedtimes. You gotta stay up late. Interesting. If a person is chosen at random from those who recalled at least one dream, what is the probability that that person belonged to Group Y? So first off, it's worth pointing out that you can ignore everything other than this. Right? All of this is just fluff. You don't need to read any of that. If a person is chosen at random, we got this table up here, who recalled at least one dream. So we're saying they're in one of these two columns, but we don't know which column. So how many people are we dealing with here? Well, we're dealing with this many people. There's a total of 39 plus 125. In other words, 164 people that we're talking about here. So if one of these 164 people is chosen at random, what is the probability that they belonged to Group Y? Well, of those 164 people, 79 of them, maybe this should be in a different color, although I guess the colors don't really matter, belong to Group Y. So I take this 11 plus 68, I get this 79. And so 79 of these 164 would fit in Group Y. So this will be exactly my answer. This is the probability. I look over here for 79 over 164. I find it in C. I call that good, and I move on. 22 and 23 refer to this table. So these are the annual budgets for different programs in Kansas. So years, here's the program, here's the years. Okay. When they're all in thousands of dollars, maybe that's relevant, maybe not. Which of the following best approximates the average rate of change in the annual budget for agriculture from 08 to 10? So what I'm talking about is the change from this number to this number. The change, I want to subtract the two of those. If you subtract the two of those, what you'll get is about 130, 488K, which are really 488 million because these are in thousands, but we'll let that slide for now. Minus 358K. That leaves us with approximately 130K. I bet 130K, or really 130, I guess it would be million because we have to multiply by 1,000 as an answer here. That's my answer, right? No. The reason that's not your answer is because it asks you for the average rate of change per year. Note that this took 2 years for this to happen. In order for me to get from here to here, it took 2 different years. So I went up 130 total. 130 divided by 2 leaves me with 65. So really the average annual change is 65,000 thousands, in other words 65 million, which is answer B. Tricky answer there with part D. Okay, 23. Of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the Human Resources Program's ratio of its 2007 budget to its 2010 budget? So I'm given 3: agriculture, education, highway, and public safety. So agriculture, this guy, highway and public safety, this guy, and this guy. So first what I'm going to do is I'm going to calculate the ratio of Human Resources 2007 budget to its 2010 budget. So I'm going to take 40, 51, and if you want, you can type in 050 if you want. But since I'm looking for what's closest, I can probably get away with just leaving off the last 3 digits and calculating these amounts. And if I do that, I get 0.684-ish. So that's my magic number. That's what I'm looking for. Let's see. So looking at the rest of these guys, can I rule any out immediately? I don't know. Maybe you could, but maybe it's easier to just calculate them than to think too much about it. So here I got 374, if I round that off to the nearest 1,000, which is really millions, divided by 488, and I get 0.767. Close, but not that close. What about education? Well, for education, I would get 2165, I guess, if I'm rounding, divided by 3008. And that gives me 0.71, 0.720, I guess. I'm getting pretty close. Certainly closer than that one, so I know that this is not my answer. What about highways? I got 1468. And I want to divide that by 1774. And I get 0.82. Yeah, that's nowhere near 0.828, I guess. I probably didn't even need to calculate that, right? 14 divided by 17, that's no way that's only 0.60. I mean, this number is so close to this number, percentage-wise, that there's no way it has the same change as those guys. Okay, I already calculated it. Public safety, it's the last one I got to do. 263. For this one, since these numbers are pretty small, maybe it would make sense to include another decimal place. You can if you want. But I'm just going to call it 263 and divide that by 464. And what I get for my answer is 0.567. So remember, this was my magic number that I was trying to be close to. It looks like this one is the closest, right? 72% is close to 68%. They're only off by about 4%. These are off by 12%. These are off by a mile, and these are off by 8 or so percent. So my answer would be that education's ratio is the closest. I get B as my answer. 24. Which of the following is the equation of a circle in the xy plane with the center 0, 4 and a radius with this endpoint? Okay, that's a little bit tricky. What you need to know is the equation of a circle is x minus the center, the x-coordinate of the center squared, plus y minus the y-coordinate of the center squared has got to be equal to the radius squared. So the x-coordinate of the center, which some books use a k to represent, it doesn't matter what letter you choose, is 0. So in my equation, I'm going to have x minus 0 squared, in other words, x squared. And the y-coordinate of my center is 4, so I'm going to have y minus 4 squared. And that's equal to r squared. Let's see what I can rule out so far. I can rule out this guy and this guy. Right? It must be one of these two answers. All I have to do is figure out what is my radius. The way I can figure out the radius is using my distance formula. If you happen to know the distance formula, the distance between 2 points is the square root of the difference in the y-coordinates squared plus the difference in the x-coordinates squared. So you could just go through and plug in numbers. You could call this x1 and y1. You could call this x2 and y2. And so you could say, all right, the difference in my y-coordinates is 5 minus 4, which is 1, plus the difference in my x-coordinates, which is 4/3 minus 0. The distance between these two is the sum of those two squares, which this is 16/9 if you square this thing, and then this would be 9/9. So 16/9 plus 9 more ninths is 25/9, and the square root of 25/9 is 5/3. And so you're like, oh, this must be the answer, right? No, it's not. In fact, this is your answer, and the reason why is what goes on the other side of your equation is your radius squared. So this number squared, 5/3 squared, is 25/9, as we kind of saw over here. So 25/9 would be what goes over on this side, and A would end up being my answer. Let's see, some other ways you could get there if you didn't know this equation of a circle is you could realize that this point right here is on my circle, right? This is the end point of the radius. This is on my circle. If I change all my x's into 4/3 and my y's into 5s, this better give me a true statement. See, I can immediately rule out this one, because if y equals 5, 5 plus 4 squared is 9, and 9 squared is 81, which is already way too big over here before I add this on. So if I just plugged this in for x and this in for y into these equations, I'd know that that is not true, and by the same logic, I'd know that it's not this one. So all I'd have to do is plug in these values for x and y and figure out which one of them, whether it gives me 25/9 or 5/3. So kind of a shorter way to do this would be to plug in these points into these two different equations. The more standard way to do it is with this sort of equation of a circle and the distance formula. 25. H, which is the height of a ball, t seconds after you throw it, is given by this equation here. And what it asks is, how long will it take for the ball to hit the ground? Well, when the ball hits the ground, the height is 0. So really what they're asking you to do is solve this equation. And when you're solving this equation, what you want to recognize is that when you have t squared terms and t terms, it'll help you to factor. It only helps to factor if your equation is set equal to 0. So if this were not a 0 right here, you would subtract whatever number this is from both sides of the equation. And I make a big point of that because everyone forgets to do that, and they'll screw that up. You'll see a problem where this is not a 0. Make sure that you only factor when your equation is set equal to 0. In this case, it's already 0, so I can just go ahead and factor. How can you factor this? Well, both terms have a t in them, so I could pull out that t, and what I would have left would be this. So what I have is something times something else equals 0. The only way that can happen is either that first thing equals 0 or that second thing equals 0. Well, I'm getting two solutions. That's strange. Well, not really, right? The height of the ball is going to be 0 the second you throw it or launch it vertically upwards, I guess. But that's not the solution I'm looking for, right? That is still on its way up. This is right when you start. What I'm looking for is this solution here. To solve this guy, I'd probably add the 4.9t over to the other side to keep everything positive, and then divide by 4.9 to get that t is equal to 25 over 4.9, which you can pull out a calculator to get, or you can be like 25 divided by 5 is 5. I'm dividing by a little bit less than 5, so this number is going to be a little bit more than 5. Oh, it says approximately, so I bet the answer will be 5. But maybe if you didn't want to approximate things, you pull out your calculator, because this is the calculator portion, and you do 25 divided by 4.9, and you get 5.1, which is damn near 5, which is the answer to this problem. These videos are getting long, so maybe I'll stop this one here.